Hey guys, good afternoon. Hope you all had lunch. And I'm Adarsh, and this is my co-founder Raghav. We are both co-founders at Tensoic AI, and we're also students at VIT Vellore. I'm 19 and Raghav is 20. So today we are here to share an idea rather than just talking about a random theory. We are here to share an idea of how we aim to adapt existing AI models to a lot of Indian or a lot of languages that are mainly underrepresented, right? So Raghav he will speak more.
Yeah, before I even get started, I want this to be as interactive as possible. So if you guys have any questions, feel free to interrupt. It's not really very formal. So, raise your hands, or even if you interrupt us right in the middle of the talk, we're happy to sort of answer your questions regarding that, right? And if I have to talk about the title of our talk, which is Multilingual Indic language models, I'll have to first start by talking about, so in early or late 2022, ChatGPT 4 came out. And at that time, I started using it. I found it so cool. I already started using it to do my homework. It was writing code for me. It could write letters, emails, a lot of stuff that I was doing normally as a student. I could automate, and my life was made so much easier by ChatGPT, right? And I found it so cool for so many reasons. And then like a couple months after that, Facebook or Meta, they released their own model, their own LLM or large language model called Llama. Llama 1 in January 2023. And why this was so cool, or why it was so interesting to me, is I could run a version of ChatGPT on my own laptop. So ChatGPT is this thing I had to go onto the internet, log in, do all that stuff. But here's a version of, or something like ChatGPT that I can sort of use on my own personal laptop. And then I started, I went on the website, I downloaded it, I sort of learned, or I tried to learn how I install it, how I use it. Then I found that, hey, I have a problem now. My laptop does not have a GPU. And this is something large language models, at least at that point, were only supported by GPUs, or you need to have a GPU on your machine to interact or use a large language model, right? So this was a problem for me, and then I started thinking, I typed in a bunch of group chats, I asked, if anyone else is interested in helping me do this, if you have a GPU, and maybe we can do this together, and that is how actually I met Adarsh even, right? And so after we met, we went around, we asked professors in our college to give us access to GPUs, how do we run or how do we use Llama? And then we found it, and then we went and we downloaded Llama. So how it works is you go and download the weights of this model, and then you perform this thing called inference, which means you interact with this model by asking questions, stuff like that. So we went and set up inference for Llama on our school's local GPU system. And then we started playing around with it, right? The same things that we were using ChatGPT for, we would just use Llama for now. We would write poems, stories, writing emails, writing code even for many of our assignments, right? So while we are in class on a lab, we could sort of learn parallelly by a Llama instance that was hosted on our school's local setup. And so this was super cool for us. This was how we worked. And it was great, right? Initially, this was so surprising to us that it could work so well on our systems, or it could work so seamlessly, and we were so benefited by it. But there was one slight problem that we felt. So, I speak Tamil and Adarsh speaks Hindi, right? And that means that sometimes I think in Tamil a lot, or I might want to say or do something in Tamil, and he might want to say or do something in Hindi, right? And Llama does not support Tamil or Hindi for many reasons. But that sort of makes it a gap or a bridge that I can't fully use. I can't transmute all of my thoughts into Llama. And that has a slight problem. So, that's where this whole idea begins, that you're not able to effectively transmute or translate your thought into the language model itself. And we'll get into the next slides and discuss more on that idea.
Yeah, but just to summarize, ChatGPT dropped, Llama 1 dropped. We got very curious. We went on the internet. We found each other. We went to our school, the HOD, and we were like, just give us GPUs. They gave us a 1 crore machine. They just gave us the access to it, and we were like, we went like crazy on it. And yeah, so that's how we started messing around with language models, large language models. And the main issue is so I was in my native just a few days ago due to a family emergency, and what happened is a lot of relatives came up to me and were like, can you fix this on my phone? Can you fix this for me? And it was like really basic problems, right? So one relative was like, if I transfer my SIM from this phone to this phone, will all my photos go away? So I was like, wait, don't you know this already? So they were like, okay, I'm not very sure. So I found out there's a lot of gap between what the current progress or the current technological progress is happening, and a lot of people in the Indic space or like in the regional level of India don't have access to a lot of cutting edge technologies that might make their lives more easier. So our main problem that we identified is like the technology currently is too sophisticated for people to use. It appears easy for us because we are a bit tech handy, but even for maybe a farmer in a village, right? He wouldn't know what ChatGPT is. He wouldn't even know like how to use it on your phone. So there's a lot of desi aspect to it, and here's what we're trying to mitigate through creating AI models that talk in your own language, talk in Indic languages, and yeah, this is the problem. So what happened when Llama 1 dropped is, I was typing stuff into it in English. It was spit out English tokens back. And once I just randomly typed in a Hindi sentence. It just spat out gibberish. It did not know what Hindi was, right? It could not understand Hindi. Suppose you're a Hindi speaker and you go to Tamil Nadu and you read a signboard. I won't understand what it's written. It's like some random stuff I won't understand. It's just gibberish to me, right? Same applies to LLMs. When you type in any different language, right, that it's not been trained on, that the model initially hasn't been trained on, the model tends to hallucinate, or the model will just spit out gibberish, not knowing the language, not knowing what it's supposed to do in that aspect. And this is where we came up, like, not came up exactly, but we found out some Chinese guys had taken an English-only LLM. They had extended its vocabulary, and they trained it further on Chinese data. So what they did was they went onto the internet, scraped all Chinese data, and they continually pre-trained the model, that is Llama 2, and they had essentially created a Chinese LLM. It could now speak in Chinese. So this is what we exactly replicated back in, I think, January 2024.
Yeah, earlier this year. So how it works essentially, how a language model learns is, computers, or how language models learn is, they're trained in such a way where humans only learn, like humans know English and their primary focus is English, but computers are agnostic to language, they're agnostic to, modalities in general, right? Which means that you can train a model to speak in Tamil, Hindi, Kannada, just the way you would be able to train it in English, right? So for Llama 2, this required you to, so there are two aspects of this training, right? A, we first make it familiar with the tokens, or we make it familiar with how the characters are represented in a new script or a new language. And B, we actually teach it like to do maybe summarization, to write a poem, to write stories, to write code in a whole new different language, right? And so we can split these two into talking about a tokenizer and the actual model itself. And a tokenizer is sort of a vocabulary or an internal representation of a new language's script or a new language's words in your model, right? And so for Llama, it has a tokenizer that is trained natively on only English, and the model as well is only English. So you have to train both parts. Is you have to first take the tokenizer and teach it that, hey, this is how words and sentences, this is how letters work in Tamil, this is how letters work in Hindi, this is how words and sentences work. And you sort of build in it a small vocabulary, a dictionary of sorts we give it, right? And then we also train the model itself, which means that we take whole bunches of data, we take newspapers, we take articles, we take storybooks, we take websites, we take all information, all textual information essentially in the language that we want to train it on, and then we feed it into the model. So the model understands this is how sentences work, it understands over higher and higher degrees of complexity, and as such it learns your new language. So that's how this works, right?
Yeah. And so we're proud to say we were one of the first people who trained an Indic language model in India, one of the first. So Sarvam AI, they're a company who raised $41 million. Even they trained a Hindi Llama. We did it for Kannada, and there was a model called Navarasa. I don't know if many of you might have heard it. It was featured on Google I/O, the official main Google I/O. And we were the ones behind helping train it. So we essentially got a lot of traction with it. A lot of people reached out to us. They were like, hey, could you do it for my language? A very rich community from the American Jewish community reached out to us and were like, could you do it for Yiddish? And a Ukrainian team also reached out and we were like, could you do it for Ukrainian language? So we trained a model, we published it, we published a research paper along with it. So there's a lot of untapped potential for training AI models in underrepresented languages. The internet contains only and only like a lot of English and maybe Chinese data. There's an inherent lack of multilingual data that exists on the internet.
Because people are talking to their friends and family, and people usually interact in what is their native language, right? But the way they use the internet is like completely different. Your relatives, even very old relatives who might not be totally familiar or comfortable with English, often would type in English characters or letters, right? But how do we bridge this gap? How do we make the models itself? Because these are the people, someone like you or I, we're native to tech, or we've grown up with this all our lives. We know how these systems work. We have some sort of intuition for this. But the people who would be more, who this would benefit the most, right? Who would actually benefit by the most simplest of questions, something like he said, does your phone change language or something if you change the SIM? Right, so a person who might have a question like that, instead of typing it into Google, if they typed it into an LLM, it would give a much more nuanced or much more explanative answer, right? So our problem itself is about how do we bridge this gap for those kind of people across not just Indian languages, but languages across the globe which are underrepresented in these models that exist on a global scale.
And the reason why it's extremely important for us to develop our own language models that speak on a multilingual level for population scale is a lot of it's like a geopolitical play, right? You have to have your own intelligence. You can't depend on a US based, like you can, but you can't depend solely on some other countries, AI intelligence or like models, right? You have to be self-sufficient. And we have seen a lot of case studies. Mistral AI, they raised $100 million just based on a 7-page memo. So there was a Word document, you could go and read it. They raised $100 million. Sarvam AI is an Indian AI startup, co-founded by, I think, IIT Madras professor as well.
Yeah.
And Sakana AI is another Japanese-based startup. They raised 200 million. And all these companies focus solely on regional AI models. So they are essentially researching into new methods and new methodologies into developing AI models and adapting them to regional languages.
Yeah. So it's not just about benefiting people who are underrepresented. It's like there's a social angle to it, but there's like a huge political, economic angle as well, where the people or the countries in which these state-of-the-art systems are built get to make the rules and laws around how they are used, where they're allowed to be used, how to collect data from people and use them to train or interact with these models. So it's imperative for people like us, in if you call it a less developed country, to also build these systems to the state-of-the-art, so that we also have control on how our users' data is represented, how our users are being, how they're being used for the data essentially, is something that you'd like to have in your own country. So that is another.
Yeah. So current AI, how many of you use like the image upload option on ChatGPT? Like, I think a lot of you must have just So LLMs essentially are not just text only. We can adapt them to a lot of modalities as well. You can adapt LLMs to audio, text, and vision. Vision meaning you can upload images and you can upload videos, and audio meaning you can talk to the LLM. You have like an audio encoder that encodes all your audio into, and then have it represented as text tokens that the LLM can understand. We'll go deep into it, but our main focus here would be vision, as we focus a lot on vision language models, and we are essentially training models that can read more than 500 plus languages. We would be explaining a data pipeline today that companies, like a SOTA data pipeline that companies would be using to adapt existing vision language models to 500 plus languages. So that's our main research goal, and today we're here to explain about that. So explaining what's a vision language model. So you just might have just uploaded onto ChatGPT and asked it, okay, can you explain me what's happening here? Right. So there's a very clever and intuitive process that goes on behind it. You have your image that's uploaded into the user interface. What happens behind the scenes is that image gets splits up into patches. there may be different methods of splitting them. Maybe they'll cut it into 4 squares, or maybe they'll cut it into 16 squares and then have it, intelligently placed. But essentially, what happens is your image goes in, it gets cut into patches, and there's a thing called vision encoder. How many of you heard vision encoders? Clip, siglip? Not a lot. Okay. So, what vision encoders do is they vectorize your image. They take the RGB values of your image in pixels and they convert it into vectors or embeddings as such. And what happens is these embeddings represent your image in the form of tensors, or like it's like basic embeddings. So there's this entire pipeline that you paste in an image, the image gets embedded, it's called embedded. You take the embedded vectors, you project it so that the LLM can understand you. So it's in a different dimension. The LLM still can't understand what's happening in the image. You project that embeddings onto a layer that, onto a dimension that the LLM can understand, and then that is fed into the LLM, the actual large language model backbone, and then the model can understand what's actually happening in the image. So it's like a human being being able to see, a human brain, that's the LLM, being able to see an image, and it can answer based on it. So this is a very brief idea of how vision language models work, how ChatGPT on your backend works, how Claude or any of the Gemini, any of your vision language models that can see, or essentially see images, videos, work on a very brief.
Yeah. And the problem here, sort of, like what you're trying to explain, is that the way these models are trained are like humans have trained them, right? And humans sort of understand or parse different modalities. Human understands the difference between speech, text, or vision, let's say, or an image, right? But inside the internals of a computer, all of this is just ones and zeros. So what we do while adapting to multimodality is how do we convert an image to representations that look like text? So however a model represents text internally is how we want to make it represent images as well internally. And the same learning principles apply in both places.
Yeah. No. So we take frame by frame, we patch it up, and then we put it in sequentially. So there's a context length, right? There's a maybe 8K context or 32K context length. So current LLMs can take in maybe hundreds of images at once. Not hundreds, but maybe 5 to 10 images at once. So we can break it up into appropriate frames, maybe 5 frames a second, and we pass it into the image, the vision language model. But it's sequential. So you take image patches, and those patches are processed sequentially. So the LLM can maintain context over the entire video duration, not just one single. Okay, so a lot of you might be wondering, like, how are these, models trained? What does the data look like? Have you ever wondered what the data behind ChatGPT training looks like, or a vision model looks like? Nobody might have really tried to understand it, but here's an example of what exactly the data behind a vision language model looks like. The LLM also, a language model also works similarly, but you essentially have an image, and the image goes through all the processing, like getting encoded and being projected onto a different dimension. And then you have a very nice format that says that from a human, this is the input, and the human there's an image token there. You can see there's a image token, and after the image token, there's a prompt that says provide a brief description of the given image, and then there's a value from GPT that says, that describes the image, essentially. So the value is a set of 3 chrome and bubble table lamp classes. So this is what raw data looks like. And we are essentially trying to generate or synthetically create this data. And coming more on that later.
Yeah. Because data and information like this is scraped from the internet, which means a lot of these images for Wikipedia, for example, have captions, everything available in English, right? This is another problem because that we face, that, hey, a lot of these information is available in English. There are images, there are descriptions for these images in English, but for an Indian specific image, there might not be, right? For Indian cultural context, stuff like that, for so many very like niche use cases in Indian context, this isn't there. So we're also trying to bridge that and for that reason, we're creating our own data sets or like synthetically generating stuff like this so we can train and make our models understand different Indian languages or low represent resource languages.
So what we did recently was, how many of you heard Gemma? I mean, most of you all might have heard Gemma, right? Yeah. So what we did was we created our own GPT-like vision model from scratch using Gemma and Siglip. Both are models released by Google. Gemma 2 billion parameter, it's a 2 billion parameter model, and Siglip is an image encoder. It performs comparatively or better than Clip at smaller batch sizes. So as a fun experiment, we were like, okay, let's just train a vision model from scratch, right? So we did train a vision model. How it works is, as I explained, there's an image encoder, that's Siglip in this case. The images go in, it gets embedded, it gets projected using a 2-layer MLP, and there's the LLM backbone is Google's Gemma. And you have a very nice representation of how it looks. So we inputted like an image and we asked it to describe the image, and the model's output was the image is a playful and surreal depiction of a man in a spacesuit sitting in a chair holding a green beer bottle. And then we were like, Mario, and what's funny about this image? So even like two stupid guys from maybe a college can train a vision language model. You might think it's easy. It is. Trust me, it's very easy. But there's a lot of, there's a lot of things that could go wrong here. One thing essentially is everything is English. There's no Hindi, there's no Kannada, there's nothing. But so we essentially thought how we could scale this to different languages, how we could scale vision language models to different languages. So that's how we came up with the. What's stopping us is the data, right? There's no data. You have tons of data for English, tons of data for Chinese, because Chinese inherently use Mandarin in their scripts on the internet as well. But data is the main blocking. Apart from a million GPUs, you need a lot of compute as well, but the main factor is data. You don't have data, you don't have a model. So that's what we tried to do here. You need high quality, clean, diverse data. So this is our upcoming latest project that we're trying to explain and trying to do.
Yeah, is that we want to make it really simple, really easy to train a vision language model in any language that you choose. Doesn't have to be an Indian language, doesn't even have to be a language that maybe has a script even, right? We want to take any language that you can think of. You should be able to interact with a model that is able to understand that and able to give you images, able to talk to you in that language even. So stuff like that, we are trying to create a pipeline that enables you to train or teach a model to speak in any language that you want.
Okay, so this above chat is from a guy who works at a very big research lab. I won't name the lab. It's a multi-billion-dollar AI research lab. They are building the frontier AI models, and I just DM'd him on Twitter. I was like, hey bro, can you just tell me how you build such amazing vision language models? I'm trying to find Hindi data, but I can't seem to find any. There's nothing I can visibly scrape here. So that was his only answer. Scrape as much as you can. Especially Hindi OCR, you should get good at. I was like, okay, but you're a billion-dollar company. You can handle lawsuits that are coming against you, right? If I go and scrape maybe medium, I'll have a lawsuit, a cease and desist letter in my hand the next day. So this is obviously not viable for someone like us who are working on a very small scale, but we're trying to do something really impactful. And this is where our main savior comes in, and that is synthetic data generation. So.
Right. And also it's not just about how easy it is to scrape this or not. Often it's like there aren't as much diverse information. Like if I wanted to scrape Hindi images off the internet, I'd have to be looking at like share chat memes for like 3 weeks at once. And I don't want to be doing something like that. So here's where synthetic data generation comes in. And this is a technique where, exactly how images, exactly how information is on English, for example. So you can, you can go on the internet, you can download all of these English textbooks, right? And Microsoft, they did this research paper or this project where they created synthetic data off of real world textbooks, right? So they took these textbooks that were designed for PhD courses, of like these, they took a bunch of universities, they did like a collab with them. So they got a whole bunch of these textbooks and they created a synthetic data generation pipeline as such. So what that means is they take content from these textbooks, they split it by paragraphs or split by topics, stuff like that. And then they make like maybe a question answer type data set based on the textbook, right? Or they make different kinds of data sets. Maybe there is a slightly more, maybe a lecture, maybe someone creates a lecture based on one of the topics in the textbook, right? So they create existing real world language, and maybe a textbook is limited to having a few thousand pages, but they create so much and so much of data off of just a very simple textbook, right? And this is also something, a very similar process that we undertake. So maybe there is real world documents that are represented, available in English, and you sort of know that how they look or how the layouts are represented, how the boxes are, where the names, like let's say a form, right? The name, date, all of those places are common across any language, right? A bank probably uses the same form just in a different language. So what we do is we try to mimic that layout of a form in Hindi, Tamil, Kannada, in 4 different languages, and then we teach the model to sort of understand that, hey, this is how a form looks in this language, and for anything like that. And maybe we can show you a few examples of how we
Okay, so synthetic data generation is what we're trying to do at here. Okay, so what sort of synthetic data? A lot of you must have seen those good morning messages that your dad sends on the family group, right? Good morning, namaste, namaste. Every day, it's just the rows changes, but the background is the same, maybe the text is the same, namaste. That's the only sort of data you're going to get for Hindi text in image, right? We went on to a lot of meme sites, and trust me, they were really, really vulgar. So we were like, let's just stay away from this. So how can I teach a model to read Hindi, right? So there are certain images that contain text inside them. You just keep walking on the road, you see a billboard or like a signboard, you just click an image, right? You just take a picture of that image. That image contains text, and you want the model to learn to read that text. How do I do that? How do I find images that have text inside them? And how do I safely extract that text and train my vision model? So we were wondering about this, and then we came across a really badass idea. What we did was we took around 2,000 different fonts. You all know what fonts are, right? Around 6,000 HDRIs, high dynamic range images. What it essentially means is it's just it's just images of different textures, maybe wood and maybe sky, and it's like very high dynamic range. And we take different backgrounds, and what we did was we used Blender. How many of you knew Blender? Yeah. So Blender is essentially a game engine. What you can do is you can use it to render 3D stuff, right? You can overlap 2-3 different elements and have it render, look like real life images. So that's what we did here. We created a pipeline. What it does is, you just have to give it a piece of text, and you know what that text is. And what it'll do is just randomly select a font, randomly select an HDRI image, randomly select a background, randomly add shadows to it, and it'll generate an image like that. I hope it's visible, but so we essentially synthetically created an image that contains text within it. And we also have the text, because we were the ones who gave that text, right? And that text got overlaid. We can do it, and we can do it for like any language that has a lot of fonts, there's a lot of text data. We can do it for any language. And there was like one very big solution for us, that we were able to generate images that have text inside them. And the other was finding posters. Posters, you must have seen a lot of posters that contain Hindi text inside them. But placing the text inside the image while being content aware is very tough, right? You first have to understand how the image looks like. Where do you want to place the text? how big the text should be, and that sort of stuff. And the third part is obviously OCR data. How many of you all know OCR? What is OCR? Optical character recognition, right? So it's essentially you have images of documents. You want to extract all the text from the document. So how do you do that? How do you find images of documents, man? I can't just scrape government. I had to go and scrape some government, notices. This is a government notice, by the way. So, generating, scraping is one thing. You can go easily scrape stuff and be done with the day. But how much would you scrape, right? There's no limit to scraping. There's a limit to scraping. But generating these images synthetically is something that's like really mind-blowing because of this amount of scale that we can take it to and the amount of languages we can include. All you need is just a text paragraph and a font that can handle that text, handle that script. So maybe a font that handles Tamil, you just give it a Tamil paragraph and you give it a Tamil font. It'll generate images like that. It'll generate highly varied images. So you'll have like different backgrounds, you'll have different textures, you'll have different shadows. And that's what we're trying to achieve here. We want to generate synthetic images that have text inside them so that the vision model can learn how to read. We take these images and we train a model. We train our vision model. So at the end of the day, our vision model can read text and we can speak to us in that particular language. So,
yeah, again, so like we mentioned before, how we would generate that document, for example, is that normally you go and look at, so there is a lot of documents available on the internet for scraping, etc., on government websites for in Hindi, English, etc., but they might not be completely digitized, which means that we don't know exactly what text is there, but there might be photos available of it on the internet. So this is a huge problem for us, right? Not only does the model need to understand how this image works, looks, need to be able to answer questions, but also needs to be able to understand the text inside the image. So for that, we do this thing, we just generate layouts, right? So we go at different forms, different government notices, different types of these data that have a lot of text in them that we need to identify, and then we split up those into different layouts. So there is a layout, this is how a government notice looks, and this is how a hospital form looks, this is how a lawyer's receipt looks, right? So you take a diverse set of data sources and you map out the layouts, how they look for each of them. And then we know what text goes in. So we generate the text that goes in. We put it in the correct layouts. Once we formalize a layout for a particular setup, we take that layout and then we put that layout behind different diverse sources, right? And training the model on this synthetically generated data gives us output or performance just as good as it would do on real world data. And this is something that we can generate much easier and train much easier as well on.
Yep. So another thing is generating posters, right? As I said, you need poster data as well for the model to really understand. So what we did was we generated an image. So it's just a random image of a woman. What we do is we basically identify we use some really small models to identify different features of an image. So first is a BaseNet saliency map. It extracts a couple of features from the image. And then second is the PFP and saliency map. It essentially gives you the outline of the most important object target inside the image. And then we have a stable diffusion model. We have a diffusion model that content awarely generates the text for that poster. So it's like a very brief data generation pipeline using diffusion models. By the way, if you all don't know diffusion models are text-to-image models. So you just write in a prompt, it'll generate an image for you. So it's a really cool thing. Like a lot of stuff has been going on in GenAI. And yeah, so how we exactly do it? As I said, we render the images using Blender. Blender is a 3D rendering engine. There's a lot of textures, the 6,000 textures HDRIs. We take that sort of textures, we give it a text, a piece of text, maybe it might be Hindi, it might be in Tamil script, it might be in Kannada script, and we get an image like this. So this image is very valuable. You might be thinking like, okay, what is this? It's like some random stuff. But this image is really, really valuable at scale. You essentially train a vision model based on this, and it can surprisingly read really good Hindi. And imagine a vision model in a farmer's pocket. You know, it's just running on his phone. He goes out, he clicks a photo of maybe a crop or something. It can actually talk to him in that language. He can maybe go to some new city and he can click a billboard's photo. He'll be able to understand what's written on it because current vision models don't support a lot of languages. Current OSS vision models, open source, yeah, GPT-4 and all does, because they're like big cores and they have a lot of money to gather all this data. But there's like a cheap, safe way of generating images you can use to train vision models and adapt vision models to like as many languages as you want. And yeah, this is the training the VLM. As I explained, you have a vision encoder, you have the language instruction. The image input looks something like this. Where did it go? Yeah, this is how the input looks like. This is the image instruction. Yeah, so the image input goes in, the language instruction goes in. You have a vision encoder, maybe it's a clip. You have a cross-modality projector. That's a 2-layer MLP. And both of the outputs go into embedding alignment. It's like a lot of maths behind it. But just think of it as you gave it an image. It breaks down that image. The language model still does not understand the vectors inside the image. So you bring it down to a dimension that the language model understands. That's called the projection. The cross-modality projector does that. Then you feed both of it into the language model and you train the language model. So essentially you have a vision language model, not just any text-based chat system. You have an actual vision language model that can understand images. Yeah, so, okay, as you asked how we could maybe do video as well. So what you have is a lot of, video essentially consists a lot of images, right, in frames. So you break up the image, the video into frames. You pass it through the visual encoder in a series, and you have like a series of embedded outputs. You can pass it into the LLM that it can understand. Yeah, so this is like a very social thing. I personally believe that there's a lot of untapped potential because I see people not even knowing that ChatGPT exists, let alone ChatGPT, knowing how technology works. And there's a lot of gap. We trying to minimize that gap, but there's still a lot of it. And a lot of it won't be solved until we push forward. And the big cores won't push for it. The big cores will only push for businesses and, people that will give them a lot of money. But we need to empower these lower strata of our, our community that don't understand English. They might rely on different languages, and that's what we are trying to empower people here with. Our main goal here is to train vision models that can read a lot of languages, not just Hindi. We have to adapt these to like 100 different languages, and that's what we are trying to aim here. Yeah.
Yeah.
So one question is, are you planning to build a framework out of this?
Yeah.
Open source kind of framework where you mentioned how to have the inputs and how to build the outputs?
Yeah. We're currently working on a complete data generation framework as well as the training pipeline as well.
So you would open source it or you
Yeah.
Yeah, we would open source it, but maybe some advanced versions of it, because
And the other question which I had was, when you talk about reading languages, right, multiple languages, so there is one large segment in India who writes in a specific language, let's say Indic or Indic, but they will write in the Roman script.
Yeah.
So have you taken that into account while doing this?
So while training or generating the data, we actually have data in English as well, right? Which means that so not only do we train on Hindi Devanagari script, we also train the same thing in English. So yeah, because a lot of times even how we scrape data of the internet, like if there are these screenshots of chat messages in Hindi, right? Sometimes they are like typed in, like you said, they are typed in English. So yeah, we do account for that sort of stuff while training the thing as well. But yeah.
There's still a lot of nuances to it. I mean, like
I think models are
nitty-gritties.
slightly better at understanding Hindi in Roman script. So the ultimate goal is to make them just as good at Devanagari script. But sure, that is also something we do consider while building.
One thing is these. Yeah, sorry. No. Go on. Yeah, one thing is these models can generalize really well. So once you train it on English, maybe it can generalize on maybe Marathi, like Roman Marathi as well. So, and a lot of this one very good thing about Indian languages is a lot of them are related. So even if I don't know Tamil, I understand a little bit of it because I know Kannada. Because a lot of tokens overlap. There's a lot of overlap between different languages here, right? Yeah. 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 Yeah, yeah. Yeah, yeah, yeah.
Yeah. I mean, I think the first step is to just get it to speak Tamil in general. And I think it's step by step. That is also something that you consider. There are like dialects as well. There are some languages that might not have scripts. Some languages are just spoken, right? So yeah, the first step is just to expand it on language, like agnostic of all these small nuances, and then we go in deeper and deeper and sort of get to it when that comes.
But when you get a lot of data, right? When you scrape a lot of data from the internet, you gradually pick up all those nitty-gritties there, right? Maybe Chennai is being written differently here. And maybe in a news article, Chennai is being written as maybe Chennai. And in another news article, it will be written as something else. So these nitty-gritties are eventually picked up while we scrape a lot of data. So, yeah. Yeah, no, please. Yeah. Yeah, yeah, yeah. Yeah, yeah. So essentially, LLMs are just huge neural networks, right? And these neural networks have been trained. What I mean by trained is you pass in text into it, and you essentially twist those tiny knobs. You can think of it as a huge pipeline of water, and essentially one information flows in through that, and that information modifies these tiny knobs of the pipeline. That's called the parameters. You've heard of parameter-based language models. So when the information flows through it, the LLM essentially learns that information. You don't have to pass it again. It has already learned it. There's also a thing where it stores this data. It's called the MLP, the multi-layer perceptron. That's where we believe an LLM stores all its information. So you don't have to pass all the training data again. You just train it once. The LLM essentially remembers all of that. It remembers the state, and yeah, you just put in your prompt. You don't have to put it the entire training data again and again.
Yeah, I think that's our time for today. But then, if you have any questions, like we'll be here, so you can come over and ask us anything.
Yeah. Yeah.
But yeah, I guess.
Thank you guys. I hope you
yeah,
guys.
Thank you everyone. You've
enjoyed.
been.
Thank you.